we are going to write some formulas, which are just like recipes. There actually are recipes. So with an equation, we got our reactants on the left and our products on the right. And the name kind of tells you what everything is. So this would be a simple equation. You do need to know the difference between reactants and products. And again, the names tell you what they are. Reactants do what? They react. And products are produced. Okay, so it stands to reason that reactants, what reacts is going to be on the left side. We're going to start with that. And the products are the result. So products are going to be on the right. You see we got some pluses to separate things. Okay, the plus doesn't necessarily mean they're combining. Just that's how we separate things. And we could have a variety number of reactants and a variety number of products. Okay. Now you have this chart in your book, so you don't need to write it down, but just some highlights. Again, plus to separate. Arrow shows you which direction the reaction goes. Generally right to left, or left to right rather. Sometimes it goes backwards. It can go in both directions. That's for later chapters. And then our states of matter, you got solid, liquid, gas. And then this is aqueous, meaning something's dissolved in water. Okay, these other two things I don't want to deal with right now. We'll come back to those. So here's a lovely first equation. Have put some hydrogen peroxide on a wound to get some bubbling. And so the equation tells you what's going on. We got some hydrogen peroxide, a single reactant. And it's going to decompose. It's going to break down into two things, water and oxygen. Okay, so this would be a word equation. Tells you what's going on. You can read it just like normal everyday conversation. Hydrogen peroxide reacts, makes water and oxygen. This is another familiar reaction here. At home, you cook something on the stove. This is what happens. You have methane combining with oxygen, and our products, we're producing carbon dioxide and water. Okay, now, first we're going to write some skeleton equations. Now, some of you guys might be familiar with balancing. Okay, we're not going to balance at first. We're just going to write some basic, simple skeleton equations. That just means an unbalanced equation, and that'll make more sense in a few minutes. So let's say, here's the reaction here. Iron and oxygen make iron 3 oxide. So if we want to make this into a chemical equation, I'm just going to translate these words. So iron, we know, is Fe, and it's going to combine with oxygen. What am I going to write here? O2. This is diatomic. If you haven't memorized your diatomics, you want to go back to your last vocabulary study guide and look at those. Oxygen is always O2. Those two things combine, then they make iron 3 oxide. Now our formula for iron 3 oxide, well, remember, this is our charge right here, 3. And oxide is oxygen, that's group 6. So if I'm in group 6, I want to gain 2 more electrons to get to 8. And I crisscross my charges. And that's my chemical equation. All right. So now here you have a chemical equation. And we can translate this into words, just an everyday sentence. So if I wanted to read this to somebody, what would I put? So I want you guys to translate this just into English. So write this as a sentence, just like if you were telling somebody what happened here. All right, so there's our sentence. Yours doesn't have to be exactly the same, but essentially that's what's going on. We got some solid sodium. It's going to react with some water. We don't have to put the liquid for water because everybody knows. It's understood. And that's going to produce sodium hydroxide. Remember, hydroxide is a polyatomic. You should have that memorized. And it's an aqueous solution, and it makes hydrogen gas, the G for gas. So let's go from a chemical equation to a sentence. So for this next one, go ahead and take this sentence and write it as a chemical equation. All right, so I got some sulfur. It's burning. That's just another way of saying it reacts with oxygen. Again, oxygen is diatomic, so it's always paired up. and then it's going to form sulfur. Prefix di means 2, so sulfur dioxide. All right, here's another one very similar. Go ahead and do this one. So I have some magnesium combining with oxygen. Oxygen's always paired. Magnesium oxide, that's a compound. You should remember that from the last few chapters. Magnesium's in group 2. Oxygen's in group 6. So if it's in group 6, it has 6. That means it wants 2 more. And if I crisscross those, and then 2 to 2, you got to reduce down. That's going to be very important for these things. So 2 to 2 is the same as 1 to 1. All right, any questions on this? All right, so you'll notice I have 2 oxygens here, but I only have 1 here, and that's okay at this point. We get this formula from our rules from before. Okay, this what comes out over here has nothing to do with over here. And just to emphasize that point, when I make a compound, what I like to do is I put everything in brackets. Once you figure out the right formula, you cannot change what's inside. So don't ever change a subscript. And we'll see why in a few seconds. Alright, so very important distinction, subscript versus coefficients. Okay, if I have H2, this is a subscript. It is below, it is sub, it is underneath. If I have 2H, that is different. This is a coefficient. Okay, a subscript means they are bonded, they are connected. This is a hydrogen molecule, whereas this over here is just 2 hydrogen atoms. Whoops. That are not connected. Alright, so very important difference. Subscript connected, coefficient not connected. Alright, so here we have a balanced equation. Now, what we want to do is, those previous ones were skeleton equations, they weren't necessarily balanced, but this one is. Notice I have coefficients in front, I have subscripts on the bottom. Okay, so again, the brackets tell you whatever's inside cannot change. I have a bicycle here, it's got 2 wheels. They are connected, they are bonded. Over here, 2 wheels, they are separate. I could give you one, I could keep one. So you'll notice whatever comes out is equal to whatever comes in. Now, okay, so right here you see a chemical equation where I have 1 carbon, 2 oxygens, and I get carbon dioxide. So what's happened is these 2 things collide and they rearrange and they give something new. So when you have your carbon for lunch and you breathe in your oxygen, those 2 things combine and you breathe out carbon dioxide. So if I take in 3 atoms, I have to put out 3 atoms. Okay, and this is again called our law of conservation of matter or mass, that whatever I start with, I have to end with. So now we're going to balance some equations, and we have to follow that same rule. Whatever goes in has to come out. So if I get an equation like this, you see I'm making some aluminum oxide, Al2O3. And again, once they give me my equation, I can't change that. Actually, I am going to rewrite it though. And again, I'm going to put my brackets just to emphasize I can never change these subscripts. Okay, my solid, not important, I'm going to leave that off. So I got some aluminium. It's going to react with some oxygen, an oxygen molecule, and I'm going to get a new product, aluminum oxide. Okay, but now I want to balance it. And to balance it, I'm just going to rewrite this. Each element that I have, I'm going to do it on the left side, I'm going to do it on the right side. I'm going to do the same order. That's just going to allow me to compare easily. So I see I have 1 aluminum, and I have 2 oxygens. And over here I have 2 aluminums and 3 oxygens. Well, clearly that's not balanced. What I start with is not equal to what I end with. So I need to change it to balance it. Well, I can't change my subscripts because my formulas are set, but I can change how many of these I have. So if this is 1 molecule, I can change it to 2 molecules or 3 molecules. Now with my my oxygens, I want to make these the same. So I need a least common multiple for 3 and 2. What's my least common multiple for 3 and 2? 6. So I need 6 oxygens. So if I want 6 oxygens up here, I'm going to double, put a 2 in front. So now I've doubled this whole molecule. So now I have 2 times 2, 4 aluminums, and 2 times 3, 6 oxygens. So now I need 6 oxygens over here, so I'm going to put a 3 in front. So now 3 times 2 is 6 oxygens. Well, I have 4 aluminums coming out. That means I need to put 4 in. So I'll put a 4 in front there, and now that is balanced. Okay, so whatever's on the left equals whatever's on the right. Alright, so here's an equation. I want you guys to write this equation first, and then balance it. Right, so I got my equation. Hydrogen's diatomic, oxygen's diatomic, H2O is water, of course. I write them out vertically just to compare easily. Oxygen clearly is not balanced, so I can only change the coefficients. Again, I put the brackets, and then I'm going to change what's in front. So I can have 2 water molecules. 2 times 2 is 4. And now I have 2 times 1 oxygen. Okay, but now I need twice as many hydrogens because I have 4 hydrogens over here, so I need to double this. And now it's balanced. Just to show you what's going on graphically, okay, I said I got a hydrogen plus an oxygen. Okay, that's a molecule and a molecule. It's going to give me H2O. Okay, that's my skeleton equation, but you see it's not balanced. I have 2 coming in, but only 1 going out. Well, I need another water. It's a package deal. I got to get the whole thing. So now my oxygens are balanced 2 and 2, but now I have 4 hydrogens, so I need 4 coming in. So this is the same thing as my equation, but that's kind of what it would look like. All right, go ahead and balance this one.